Mr. Sandeep sir, your mic is mute. Request please unmute your mic.
Much, Sudhinder. Am I audible now?
Yeah.
Okay, thank you. So before we go to preventive maintenance and predictive maintenance, let's understand, what is the difference between these two, and on, what kind of pros and cons, and how can you understand in the different factors, where to implement which one. Now, in case of a preventive maintenance, what you do is that, as the upper part of the preventive maintenance, I have shown the flow chart in the sense you select a particular asset. Let's take, for example, a pump, or an engine, or whatever is there. So you select an assets, and then define a preventive maintenance interval. It's kind of a maintenance, right? If that interval is reached, right, that preventive maintenance task has been assigned, right, that preventive maintenance is performed, right, and this flow goes on and on, right. So that is called preventive maintenance. You prevent your your machines, your critical components to work as it is, as required, by performing a preventive maintenance or scheduled maintenance. So that is called preventive maintenance. So in case of predictive maintenance, it's more advanced in the sense, you established a base condition. In case of a predictive maintenance, it can be various parameters. I'll come back to you giving an example to understand what kind of conditions can be established, right. Now, then you install those condition monitoring sensors that is needed, right, to get those critical parameters into consideration. Now you collect the conditional data, what you have established and installed, right, and then you just identify the baseline breach, right. Once the baseline breach is been identified, you create a work order, right, you perform a maintenance, and this is how you do a predictive maintenance. So the difference between the concept is that preventive maintenance is work that is scheduled based on a calendar type, or asset run time, or some other period of time. So you can predict that one, right, based on number of hours, or a calendar time, or whatever is there. So that's preventive maintenance. In predictive maintenance, it is based on that is scheduled as needed on a real time conditions of the assets. So we don't schedule it on a timely basis, or based on some based on calendar time or asset run time. But here, if some conditions or multiple conditions, or those conditions can be very complex, or can be very easy, simple one. If those conditions are true, then we schedule a predictive maintenance, right. The second time is, as I told you, that it is time triggered preventive maintenance, whereas predictive maintenance is condition based trigger. So if condition is true, it will trigger, right. Preventive maintenance, it is low to a moderate cost, right, for implementations, because it's time based, and it's very easy simple case. Predictive maintenance, can go to a moderate to high cost based on the situations, what we have, or what conditions we have to monitor, right. From a cost benefit perspective, in preventive maintenance, you can go up to 12 to 18% of cost benefits. It will reduce. This is based on some of the publication been raised on preventive and predictive maintenance. So we get that information, and based on our analysis also from the customers, we have that one. Whereas for predictive maintenance, it can go up to 25 to 30% of the cost benefit what you can get from the from the predictive maintenance. So for predictive maintenance, what we need a kind of a maintenance software. You need some schedulers. You need some checklists. So those are the things what we need for preventive maintenance, right? For implementations and deploying of predictive maintenance, you need softwares, you need schedulers, you also need conditional monitoring sensors, so that in real time you can get the data, right? What are the pros of a preventive maintenance? It's better than a reactive maintenance. That means you're not reacting based on something fails. You are more reactive than just and that's why it is. And second is, it is easy to implement. Pros of a predictive maintenance is that it's an on demand maintenance. It reduces the downtime, because you can predict that it might fail. That means it can reduce the downtime, right? Cons, or some disadvantages of preventive maintenance is that if you don't schedule it good, right, it may be over maintenance. That might be possible, right? Or it can be a labor intensive, right? Some of the cons, as I told you, that it can be an extensive technology, but I'll show you that it's not necessary that for preventive maintenance you have to go for a very sophisticated, highly cost. There are ways in which you can start with a low cost also. And second, it is that it is time intensive to achieve correctness. Either you use MI or ML. So I'll come back to it. Now, I'm going to give you an example to understand one of the preventive maintenance, what we have done to a railway locomotive, uh, uh, you know, and monitoring their critical parameters. These locomotives were mainly used for, in the mining industry, right, where these locomotives used to bring raw material, right, like it may be coal or iron ore or whatever is there. They used to bring it from the from the from the mining place to the factory where the raw materials are processed. So it used to cover, let's suppose, I don't know, 25, 30 kilometers, 50 kilometers. That's the range where they used to, big mining industries, it is being used. So this company, what their basic problem was that that scheduled maintenance, right, was not happening as such. So and what used to happen is that last time there was a lot of breakdowns, right? It used to break down automatically, so and we were not getting enough information, enough data, what was happening behind the scene, in the sense. Then we identify, in the sense that how can we improve this one, right? Generally, in this case of preventive maintenance, if you read the guidelines from the OEM manufacturers or locomotive manufacturers, it has been strictly told that after running for X number of hours, in the sense, you have to create a particular maintenance schedule, right? And that was they found that it is being skipped a multiple point of time. And the second point they found is that even the behavior of how they are running those locomotives, that is also not been be used. So maybe they need more training to understand how to run those locomotives clearly. So what we did is that we established a very low cost sensors. In fact, to be precise, it was not even a sensors. We just connected. There was one sensors, but for running the number of hours, we just connected it to engine, and we got how many hours it is running, right? That we got this information and put it on our web-based into our cloud, in the sense. We also got from the sensors the battery voltage, and some of the parameters from the engines, for example the oil temperature of that one. Now based on this, what we did is that we defined a number of hours, and based on that schedule, what we did is that whenever there is that number of hours is completed, in the sense that the maintenance schedule has been done automatically, the system used to create a ticket, right? And based on the availability of a particular engineer, right, and based on the skills needed for that, right, we used to give some data also, how it was running, how was the temperature. So the engineers has also some amount of knowledge in the sense, and then it has been totally assigned, and with each of the ticket there was an SLA been defined. So that means you don't miss. For example, you have to perform the this maintenance within this hours. These are the critical parameters we have to change. So those kind of SLAs are being defined, and then what we saw is that there was a timely maintenance, and we found that there is a this leads to increase in the life of the locomotives, right? uh, the planned travel for engineers become more smoother, right? They used to predict, because they had the mobile phone, they can see that the next maintenance when it is there. As a side effect to this, we also found that we were able to improve the behavior of the drivers, in the sense how to optimize the usage and to increase the lifespan of those locomotives. So this is one of the examples of a preventive maintenance. Now, let's coming back to predictive maintenance. What we have found is that 60 to 70% of this organization, they want to start predictive maintenance by using AI and ML. That's really good, but you have to really look into that do you have the maturity to to get the benefit out of the AI and ML. Most Many of you, if you have already know about little about AI and ML, there are two prerequisites which is very important in the sense. First, you define a model, right? And then those models are being tested, right? You have heard about automated automated car, right? Many of them, Google and Tesla, both are working, or many other companies are also working in the sense. So what they are doing is that the models have been really tested with the real time data, right? With a very high quality of training data, right? So one of the requirements for any AI and ML solution is that you should have a very good test data and very good training data. So test data and training data has to be identified, and you have to model. If any of the model which is today also working, in the sense, if it has to be adopted, in the sense that that training data and the modeling data to training and test data has to be there, in the sense. And as good and precise you have those data, AI and ML will likely to give you more benefits out of them. Now those organizations which they think that they are not in that level, we recommend them to start with something very similar, and that's why you have a low cost solutions for a predictive maintenance, and you prepare your organizations for a AI or ML. Now what we can start, for example, is a score based prediction, right? It gives around 70% of accuracy with a very low cost, in the sense. I'll explain you what low cost scoring based those predictions are there, in the sense. And when over time, if you mature and you reach to an accuracy of 80-85%, right, with a moderate cost, and you are able to have a better scores, right? And then you can you have the data, and you have already got some benefits out of this low cost, and then I think the organization is ready for AI and ML. So this is one of the examples of predictive maintenance. What we have done in the sense, this is one of the monorail what we have implemented, right? So that public sector company was having some really problems in the sense that, those as you know, that the monorail runs on different kinds of it runs on the tires. So if you can see this one, these are different tires in the sense they have two kinds of tires. It is guide wheel and the load wheel, right? So the bigger one what you saw is the load wheel, and these are the guide wheels in the sense. So as you can see is that this is one of the car. You can think of car as a bogies in the sense. So we have represented, and this is a rag table. Online, you are getting the, it is green or not. So generally what we are checking is the, the pressure and the temperature, or the combination of this inside the tire is safe enough or not, right? So we used to create the rag table in the sense, red, amber, green, right? If green, it is in an acceptable level. Orange or amber, it is warning, and the red, that means immediate attention has to be. It also used to compromise some of the times the safety of the passengers, because sometimes it caught fire because the pressures on the tires were not good enough. Now what we have done is that we have created a score based initially predictive maintenance model, in which what we used to do is that we used to predict the lifetime of these tires in the sense, because these tires used to be very expensive in the sense, and the more the life of those tires, better it is. And most important thing is that the safety of the passengers also take into consideration. So we started with the with the score based system in the sense, based on different critical parameters, mainly the pressure inside it, the health of the tires in the sense. And based on that, you started a predictive maintenance. We found that it reduces the operational cost of the tire maintenance by around 25 lakhs per year per train. And we were to replace 6 tires out of the, previously it was and 8, but we are able to reduce it to 6, right? And out of the box, because we are continuously monitoring about the tires, pressure in the tires in the sense, we are able to increase the public safety also into consideration. Last thing I just wanted to discuss in the sense that if you have looked into the the modeling of preventive maintenance, predictive maintenance, there are a lot of, every company has a slightly different, even though if they are in the same industry, they have a different kind of processes which we run in the sense. So in this I'm just trying to show you the process modeling, and how can you build all of this into in kind of a dashboard in the sense. So what we are thinking, what I am trying to show is that, it's a very miniature description of how a thermal power plant works in the sense. So the thing is that, just like your flow chart is there, this, you can build a process, right? Telling about, where is your cooling towers, where is the condenser, where is the pump, and how they interact with each other, how they are how they are behaved in the sense, what are the critical parameters, what are the sensors value you have to do, right? So in this case, what we are trying to show is that it can be visually, someone who is very good in process designing in the sense, you can build your own process in the sense and give it rules rule based on alerts and warning. What is the minimum maximum threshold? Or I look into two sensors value, and this is, you can build this governance here itself. For example, if my condition is true, please raise a ticket, and then you can define, who the skills and the availability matrix are there. You can also monitor different kinds of assets. You can start, stop, any actions what you can define, and you can also say what kind of preventive and predictive maintenance. So what I'm trying to show is that, everything what we have showed here, you don't need a very extensive training and other things. You can, many people which, businesses just wanted to have their process, they know about their process. So you can draw your process, and you can find out which parameters, which warnings, governance, assets management, preventive and predictive maintenance, you can define it. And out of the box, any SaaS solutions should be able to configure everything, and you get this kind of dashboard where you can see a RAG report can be created, the alerts can be created, the warnings can be created, right? Tickets can be generated, those kind of things is possible, right? So this is an advanced level of how, it is easy to configure this one.
Yeah, this is Sundar. Sorry to interrupt. It's a good example, the thermal power station you have taken. But generally, I have a power plant experience, 30 years in Middle East and Europe. The supplier, gas turbine or steam turbine, Siemens or ABB or GE, they make a service contract for 20 years plus years. First of all, the preventive maintenance, there is a schedule. Yes, in spite of the scheduled maintenance, all this condition monitoring was done by the parent office, like Florence. GE is monitoring all these things. But critical item, non-critical item depends upon the customer, depends upon the budget. Like private players, they have the low budget, So let it happen, then we'll fix it. That kind of attitude. Or as you said rightly, preventive maintenance, sometimes it will be maybe expensive. For example, our car, every 5,000 you need to change the oil, thumb rule. But many, they don't change. But then they put some special oil and they say up to 10,000 you can go.
Correct.
So my thing is, it depends upon the budget, depends upon the customer quality oriented, whatever it is.
Correct. That's why if what I'm trying to show it in this process modeling is that you can choose your own process, and it's not necessary that you have to, everything has to be monitored. What do you think based on your cost and benefits analysis, in the sense you can start monitoring and looking into. Today, for example, as you told that, many of the OEM manufacturers, original equipment manufacturers, they provide this kind of critical data and information. Non-critical can be also added, right? And one more thing is that even the critical information can be put it in a cloud, and it can be in your fingertips, and not that you have to be there in the cloud or in the site to have that information. And of course, the security and other consideration has to be taken into consideration for this this to be implemented.
Oh, thanks.
Okay, I think Sudhinder and me are open for any other questions you have on this. We purposely didn't went into very technical, but if you think that we should go more technical on AI, ML, IoT, sensors, definitely we can go into that. But looking into the audience, we thought that let's give present it in a way that everyone understand. But if you have any technical questions right now or non-technical questions, please do ask us.
Hi Sandeep, Sandeep here. So my questions are like on predictive maintenance. So when we are taking any asset for suppose with few sensors and we want to predict the maintenance part, like so are we doing it for the point in time or in the future, like today, tomorrow, how it will be?
It is always a real time. So
whether it is required today, right now or not, it is like that.
No, let me. It is. So prediction is more about what is going to happen in future. So predictive maintenance is how quickly your asset is going to fail or how quickly your asset is not going to fail in the future. So looking at multiple parameters of the asset, we have algorithm designed which will tell us if your asset is going to fail in the next 100 days or 50 days, or it is going to run for years together.
So it is more
Depending on
like
how
remaining useful life.
remaining useful life, yeah, if you may call it in simple terms, yes.
So suppose some assets have some inherent failures. Like if you want to classify those failures, suppose in a pump there is cavitation or broken blade or clearance wear or inlet or outlet deposits are there. So if we have to classify those kind of failures, like in the future, how to go about that?
Generally, we have it, in AI and ML, there is some branch called decision tree and root cause analysis, right? So generally we create a model, right? And let's suppose, you train those models for, to take a decision based on certain inputs in the sense, right? So, and you can feed them that if this kind of condition happens, I'm just telling about the very, very high
Yeah,
level.
sure. Yeah.
Just you understand in the sense. So what happens is just like human brain, you looking into different parameters. For example, your pump, right? If the vibration is very high, or the sound is, because you have 10 years, 20 years or 30 years of experience, by sound itself you can, you can see that no, this sound doesn't look like a healthy pump, how it should look like, or the vibration is very poor, or it gets heated quite fast in the sense. So based on that in the sense and various parameters, the AI/ML can take a decision, right, based on the decision tree, and using the root cause analysis together with the historical data, because it continuously, picks the data in the sense it can predict, or it can give you this might happen and this is the root cause and this might be the possible solution.
Okay, and in process modeling and control, we have taken an example of a thermal plant. And
Mm-hmm.
in thermal plant, there are like thousands of parameters.
Mm-hmm.
And mostly, we have also observed because of ramping, these assets get affected.
Mm-hmm.
So how to model those ramping to identify like the performance or the maintenance of this critical asset, how it is affecting?
Can you be a bit more explanation? Just give you an example to understand.
So suppose there are three turbines, intermediate, high pressure, and low pressure.
Mm-hmm.
Suppose, and there is a ramping schedule is already decided. So based on that, like if there is a continuous ramping, like it's going up, the schedule are increasing for consecutive three schedules, and then it is coming down in the next schedule. So there is a consecutive ramping, and that
Mm-hmm.
ramping happens every like 4 or 5 hours. This the
Mm-hmm.
same patterns is occurring. So
Mm-hmm.
how to model those kind of ramping and related to the health, how it is going to affect the health of those turbine in long
Okay.
term or short term?
Yeah. So maybe it will. I'll try to explain, but in the sense that generally what we do when we model something in the sense, first of all, we take the assets, right? In this
Yeah.
case, it can be any kind of assets. Assets are there. When you are ramping up or ramping down in the sense based on the demand, generally, on evening time the demand increases, because people start using that, or in summer it start ramping up, right? If the AC starts working when there is too much hot, so in that case what we have, we identify first the models, so the assets in the sense. So in the model what we have is that you can have the list of the assets, you drag down that one, right? Then you define all the interactions which is happening with these assets in the sense. And also what you defined is that all the parameters, right? For example, all the sensing items, what you need to, or the controlling items, actuators, what has been defined. And then you define the rules based on that in the sense, what will be the ideal conditions and how it is happening, right, at a high level. This is how you are able to identify those things and create those conditions, and then create the rules in the governance out of that.
Yeah, hi, Sandeep ji and Surinder ji. Maybe if you can maybe wind up in couple of minutes, then maybe we can
Yeah.
start off with the panel discussion. Yeah, please.
Can I ask one question?
Yeah, please.
Hi, Sandeep, this is Ishan. Uh, I was just wondering, usually when we say we are using AI ML for predictive maintenance of an asset, usually we depend on some kind of historical data as well for an asset. Now, in cases where that data is not available for some reason, what can be done? Can we do a simulation on a digital twin? Would that be a good idea?
Correct, that you can do it, but I as I told you, that two important things, and I'll give you a priority. So when you have a model, how can we, in a very layman term, what I can think of a model is some kind of mathematical, logical operations, in the sense, right, to model that particular scenario. Now this AI will work only good, or the accuracy level is very high whenever what you do is that you have two kinds of data. One is the training data and one is the testing data, right? Testing data tests the models, and training data, it trains the model, right? And again you test with the test data and see that how the accuracy should increase. Let's take the image processing, right? As you give more images, right, to him to process, right, and then you test with the test images, it will improve. So that is how it generally works. Today we don't have anything where if data quality is not good, right, then how to do it. Now how can we do it in case, let's suppose you don't have data, or even if data is there, then the quality is not good. Generally similar kind of industry is there, in the sense you can take those model and first use trained implement that model, in the sense you can have the digital simulators, in the sense simulate it, right, collect some data, and then you can adopt, and then you can use it. So for example, if it is not been trained, I would not advise you to go for a critical process. We can go for a non-critical process, or if it is a critical process, can have a digital twin so that it doesn't affect the real production. You have a digital twin for this, and then you try to get the good data, train it, and then you try to implement that one, right? Generally if the level of confidence in the model is low, then we have also a human in that one, where the results is first given to the human being to look into those parameters and then take corrective actions. So as the confidence level increases, then it can be done.
All right. Great. Thank you.
Thank you. I think it was really a nice presentation.